For our next talk, and I'm super excited for this one. Here, we're going to be learning about what the whole layer 2 spectrum looks like, and especially kind of from the perspective of Polygon, previously known as Matic. And we have Sandeep and Mihailo telling us about this from their end. So both of them are here. I'll let them turn their videos on and kick us off, and I'll let them take over from here. So welcome, Sandeep, and welcome, Mihailo.
Thanks, Karthik. Thanks for having us here, and yeah, like amazing work, as always by ETHGlobal. So yeah, so thanks for giving us this opportunity also to talk, in general about the layer 2 spectrum. So we wanted to give with this presentation, give a larger flavor of something that we these days call as Ethereum scaling techniques, because there's a lot of information that gets missed in the semantics. So at the very last stage, I also asked my fellow co-founder Mihailo also. So hopefully we'll be able to give you a decent flavor of like what all is there when we talk about Ethereum scaling techniques. So yeah, so we'll get started. I see I have screen sharing, right? So this is not a presentation or anything. I have basically a very, very simple kind of, few notes. Actually, you can say these are my notes. Basically, I prepared just for this presentation. So, it's a very simple thing. So yeah. So, I mean, at a very, very, very simple level, the goal for all of us is Ethereum scaling, right? So, at the end, there are various different kind of techniques, and I've also tried to create a, kind of a spectrum in some form where you can actually see what all mechanisms are possible, and then just kind of touch base more on this layer 2 semantics also, and what exactly constitutes a layer 2, and then what might not be layer 2 but then still is working towards let's say Ethereum scaling technique. Like we'll talk about some examples also on that sense. But first of all, I want to talk about two key things here, and let me see if I have that pointer here. So the two main thing, like when we let me start from here. So when we talk about Ethereum scaling techniques, there can be a lot of different flavors. There can be side chains, which are standalone chains. There can be, a different flavor called commit chains, which commit some proofs to the main chain, Ethereum main chain. Then there are, Validum kind of solutions. And then there are kind of, layer 2, which can be pure layer 2 kind of solutions. So, let's first start from what constitutes a layer 2, right? Where we can kind of see. So two key parameters over there are, first is like dispute resolution, where you can even also see my kind of cursor, and then the other thing is the data availability. So here we have mentioned that the data availability is basically whether it's an on-chain, whether it's an off-chain, and dispute resolution is what kind of dispute resolution mechanism you are using in case the off-chain. So let's take a step back. Like, what exactly is layer 2 or scaling technique? How we are trying to scale Ethereum? We are trying to do some of these computations off-chain, right? And then so that Ethereum main chain doesn't have to have so much of computation. It has limited kind of bandwidth in that sense. So how do we do that? So these two things: dispute resolution and data availability. So when you're doing this computation off-chain, you need to make sure that if it's a pure layer 2, which is completely dependent on Ethereum, you need to see that where exactly the whatever transactions are happening on the off-chain, where the data is being kept, and how the dispute resolution will happen in case the off-chain there is some sort of fraud or some sort of inconsistency in the in the off-chain kind of computation. So these two things get very important over there, that whether the data, whatever you are computing on the layer 2, whether the data is available on Ethereum, or the data is not available directly on Ethereum layer, and then how are you going to solve the dispute? So primarily we have two main categories over there. One is like on-chain, as I said, on-chain and off-chain data, and then in dispute resolution, whether you have validity proofs or whether you have fraud proofs to kind of resolve your like dispute for let's say if there's a dispute arises, whether you're using fraud proof. That the difference between validity proof and fraud proof is, so fraud proof is, as you can already see by the name that if some fraud has happened, then you can prove that fraud on chain of using a smart contract where you provide some sort of information or a challenge, and then it can be an interactive fraud proof, or it can be a single interaction for proof and things like that. And a validity proof is more like when somebody is trying to exit from the layer 2, and and then it checks for the validity of that exit right at the time of the exiting, right? So based on that, there are you can see there are primarily 3-4 kind of mechanisms. So you have like when you have the on-chain data, right? So, and you are using validity proof, they are called ZK rollups. When you have on-chain data and you are using fraud proof for your dispute resolution, it is called optimistic rollups. Similarly, when you have off-chain data and it's a validity proof, then it is called validum. And like good example of validum can be for this thing, let's say Starkware's solution. Recently, Matter Labs also announced their ZK porter. So I think that will also fall under the validum category, because they are talking about a data availability solution on the outside, and the dispute resolution will be on Ethereum main chain. So these are this thing. And then when you have the off-chain data and then you are using fraud proof, that category of solution is called Plasma. And then you have some hybrid kind of categories also, like volition and optimistic volition. These are like more evolving techniques. So largely this is the spectrum. Mihailo, if you want to add anything more to this particular this thing, or explain more about the hybrid side of things, feel free to chime in. Otherwise, I'll kind of move to the other kind of scaling technique.
Yeah, sure. Maybe just a few quick quick things to follow up on what you said. So yeah, basically it's like this is basically 2x2 metrics. And as Sandeep already says, we either have validity proofs or fraud proofs. Validity proofs are just proofs that are proving the validity of a whole batch of transactions. And we are also popularly calling this type of proofs ZK proofs. So these are basically succinct cryptographic proofs that the whole batch of transactions is valid. And that validity proof is validated or processed on the Ethereum mainnet. And that is how actually these types of solutions are deriving security from Ethereum. So this is these sorts of proofs are by default non-interactive. On the other hand, we have fraud proofs, which are by default interactive or reactive, if you will. So what does that mean basically? For fraud proof-based solutions, it is necessary that some party, ideally the owner or the end user, so if you have some funds that are in a solution that is based on fraud proofs, ideally you should be monitoring that particular chain or that particular scalability solution. And in case you notice some malicious activity, you should ideally, or some third party that you might then necessarily have to trust, should submit this challenge that Sandeep already mentioned. So that is kind of a major difference between validity proofs and fraud proofs. Validity proofs, there is no need for that sort of constant monitoring of the scaling solution, i.e. activity in it. So that is, I would say, one advantage of validity solutions. Unfortunately, the trade-off with validity solutions, there are multiple, I guess, all solutions of course have trade-offs, but basically validity proofs tend to be larger in size, tend to be computationally intensive. It is kind of not trivial in terms of computational power to generate these ZK proofs. The cryptography is still being improved. Many of these solutions, excluding probably only Starkware, because their validity proofs are based on Stark, which is a separate type of or separate flavor of cryptography that doesn't require that thing called trusted setup. All other solutions are actually requiring that trusted setup, and trusted setup is basically a ceremony where you generate some initial parameters that are required to actually later produce these validity proofs. And if at any point this ceremony, this trusted setup ceremony is compromised, there can be basically any sort of exploit, and the entity that managed to compromise the trusted setup is able to basically steal users' funds and steal them in a very, if I may say, catastrophic way, because the Ethereum mainnet would just process that fraudulent validity proof without even being aware that it's fraudulent, because the setup is compromised. So yes, I mean, we could talk for hours basically about these solutions, but yeah, and maybe just on the other side, to cover the other side of the matrix is, and that is basically where the data is stored. If data is on chain, the situation is very clear in a sense that that's the highest level of guarantee that the data is available. But and that's why these solutions like optimistic rollups and ZK rollups are so popular recently, because it is like a trivial way to solve data availability problem that is basically a pretty challenging problem. And however, the major downside of storing data on chain is that you're kind of continuing to clog the Ethereum mainnet. And we all know that the capacity of the mainnet is very, very limited. And that is why we should, I guess, as a community, be aware that optimistic rollups and ZK rollups are very exciting solutions, but they are not, unfortunately, long-term solutions for Ethereum scalability, because again, we are storing all this data on the Ethereum mainnet, thus ensuring really high guarantees for data availability, the highest guarantees, but we are significantly limiting throughput of such solutions. So to put that into perspective, ZK rollups and optimistic rollups can offer us maybe 2 orders of magnitude of scalability improvement, which is, I guess we will all agree, not that amazing. On the other hand, these off-chain data availability solutions don't have that trade-off, but it is, as I said, data availability is a challenging problem, and it is pretty hard to ensure or guarantee data availability if the data is off-chain. So there are basically many techniques that are being explored, but none of them, of course, can offer the guarantees of Ethereum. So with any scalability solution, basically the point is it's all about trade-offs.
Exactly. Yeah. So as you already saw that, you know, the on-chain, like with this kind of category on-chain data, it's really secure, and that's why we call them rollups, because even if, let's say, the layer 2 setup completely goes for a toss, you can actually, you know, roll that chain, like, you know, kind of create that chain back from the available data. So it's much more secure, you know, in terms of any fraudulent kind of events or fraud events. But then it has limitations because the data is on Ethereum main chain. Same, but with off-chain data, that trade-off is not there. But then if the data availability setup goes for a toss, then you know, it can be catastrophic, as Mihailo mentioned. Coming to the then other kind of solutions, how, like, you know, these, like, again, the pure layer 2, because see, again, on a higher level, if you see the trade-offs, at the end, you want Ethereum to safeguard the off-chain setup. So if you want Ethereum to safeguard the you know, layer 2 setup, then it is going to be costly. So and then, you know, there can be a lot of use cases where projects do not, or kind of the solutions that are being developed, they do not want let's say that high level of security. And like, for example, some sort of NFTs, like, small ticket size NFTs, or somebody is issuing, let's say, tickets of the events and things like that. So there are huge number of use cases wherein you might not need that level of security. Like Mihailo at times gives that example that do you want like a global level, like Ethereum main chain level security for a like a convenience stores transactions, right? So it might not be required. So the philosophy, and then like right now we are not speaking too much about the Polygon, but the idea of Polygon, or the core thesis of Polygon, revolves around this, that Ethereum is going to be the ultimate settlement layer. And then on top of it, you will have all of these different techniques, like layer 2 techniques. So, for example, we are also working on some of these optimistic rollup, ZK rollup related, techniques. We have our Plasma, solution, and like the proof of stake or the commit chain solution already live. We expect to, kind of launch like more solutions, like which I'll talk about, like shared security solution for Ethereum, which, let's say, the popular example for that is, let's say, Polkadot, where Polkadot is trying to create a shared security layer which will be a central chain, and around that you will have para chains. So what we want to eventually build is, and in some form, the Matic POS, because it works using a validation layer. If you want to go deep into that, maybe we can talk offline, that there is a sort of a beacon chain, and on top of which the Polygon commit chains work. So they can actually, the same security setup can spawn off multiple such chains, right? So that will kind of in some form might look like a sharded kind of architecture, or like a Polkadot kind of architecture on top of Ethereum. So our approach is that what Polkadot is building as a separate ecosystem, we want to offer that opportunity for the Ethereum developers, wherein they can spawn off their like I don't want to call it para chains, but let's say standalone chains, using shared security mechanisms run by the Polygon validators, and they all kind of center and connect into Ethereum. So that's one way. And then you can also have standalone chains. So standalone chains means, for example, standalone chains can be like there's like Lazy Ledger is one a very off example, although it's more into data availability. But then the examples of completely standalone chains can be, let's say ETHGlobal chain, which is has standalone consensus. Everything is separate. Or you can think of like Cosmos like chains, which are completely standalone chains. So with Polygon, and we are coming out with something called Polygon SDK in some time, which will be like something like what you have Substrate in the Polkadot ecosystem, or Cosmos SDK in the Cosmos ecosystem, wherein you can spawn off these Ethereum compatible or EVM compatible chains, which can then work on top of Ethereum, or readily connect to Ethereum. And then finally, I want to lastly, kind of show this spectrum that, this Ethereum scaling techniques, like whenever you are thinking about it, think of them as a larger kind of, larger like larger spectrum, wherein on the complete left side, you have a lot of side chains which are contributing back to Ethereum. Like, there is like XDAI is a very good example. That's a completely standalone chain, but they are hosting quite a lot of Ethereum applications. Like people are building a lot of casual as well as some DeFi applications, and DAOs have been built on XDAI. So they are also contributing back to the Ethereum ecosystem. Similarly, the next and when you see this line, basically consider the left extreme, the sidechain extreme, as completely standalone, which does not depend on Ethereum's security at all. And then the right extreme that you can see, where I've posted as layer 2, this right extreme is completely secured by Ethereum. So, and then there are multiple these things in between. So sidechain is on the left spectrum. Then you have Polygon PSS's commit chain, where everything the staking happens on Ethereum main chain. The slashing, the reward systems, everything is on Ethereum, and this is a very, very kind of coupled chain to Ethereum. And then if let's say there is some fraud happens, On the layer 2, if it is Plasma, then you can actually, exit your funds directly from the main chain. But even with the normal POS chain, if there is some fraud happens, at least you have the slashing available for the the validators which are validating the commit chain. So that's one layer above, let's say, a normal sidechain, and that has some security benefits in that sense. But then one layer above that would be, let's say, Validum kind of solutions, which, as Mihailo was explaining, that the data is these are pure layer 2 solutions. But then if, let's say, the data is being stored off chain, there is certain level of trust assumption of the the off-chain data availability providers. If they go for a toss, then it can be catastrophic, as Mihailo mentioned. But as far as that layer is secured enough, you have a fair amount of security of the Ethereum main chain. And on the last and the biggest, like the most secured solution by by Ethereum main chain are your pure layer 2 solutions, which include ZK rollups, optimistic rollups, because they're both dispute resolution and the the data availability is directly on Ethereum main chain, so they are more secure. There are other solutions like State Channel and Plasma, which have been explored before. Plasma has, like, although everything works fine for transfers and all that, but then there are scenarios of, let's say, mass exit, wherein like some chain goes off and then everybody is trying to exit and Ethereum main chain gets clogged and all that. So those kind of scenarios are there, but then there are mitigation techniques, with dynamic withdrawal periods and things like that. And with state channels, like, it is specific to, or kind of, people have, or the community has realized that they are useful for certain kind of mechanisms. If you want to see state channel based solutions, you might want to look at, let's say, Connects network, who's building now this layer 2 and layer 1 bridging solutions. So those are also, interesting solutions. Yeah, and on somewhere between this layer, like, I think before that, I think Scale Network was doing the presentation. So Scale Network will also lie somewhere here, because they are because I think their staking and everything also happens on Ethereum main chain, if I'm not wrong. So they will be somewhere between here. So that kind of, this gives you a rough kind of spectrum of the Ethereum scaling techniques. Mihailo, if you want to add anything, please feel free to add. Just before
Yes,
we
basically, as Sandeep said, Ethereum scaling is definitely a spectrum, and all these solutions have different trade-offs. And as Sandeep said, there is this left extreme side, which is completely standalone chains or solutions, and on the right side, just a small, basically, correction. Plasma should be in that section before the last one, because Plasma also has off-chain data availability. But basically, I will kindly ask you to forgive us. We were not really prepared, honestly, for this presentation, because we thought actually it's going to be a panel, believe it or not. So yeah, I think you can forgive us, because this was last minute kind of for us. Anyways, just to maybe add a few things regarding Polygon. We at Polygon are, first of all, in love with Ethereum, and in among other things, in Ethereum scaling ecosystem. It is amazing in a sense that many different independent teams with lots of brilliant people are working on these exciting solutions. And it is an organic ecosystem, and again, we really love it. But we believe, number one, that there needs to be some sort of structure to this creative chaos of Ethereum scaling ecosystem, and that's where we see the place for Polygon. Polygon is basically a project that aims to introduce structure in some way to this beautiful, organic, but somewhat chaotic ecosystem. Also, we believe that we are still very, very early in terms of infrastructure maturity. Ethereum as a project aims to kind of build alternative financial global ecosystem, and basically to change the way we collaborate, we work with each other, even the way we organize ourselves. And and it is like a very, very transformative idea, and the infrastructure, building the infrastructure to actually achieve that idea, that will actually able to onboard billion plus people to actually use this system is going to take time. So we as a community, of course, and as human beings, we really want things to happen today if possible. But in our opinion, that is not going to be the case, definitely. Ethereum is 5 years old, and Ethereum scaling solutions are generally like 3 years old. And to achieve this great vision, great dream of Ethereum that we all believe in, we believe it's definitely going to take years of hard work. So when people say this is the year of Ethereum scaling, we believe that is unfortunately definitely not realistic. And with that in mind, we just want to kind of facilitate further innovation on the Ethereum scaling front. And there is that famous misquote that says, "Let 1,000 flowers bloom." So that's what we want to do with Polygon. We want Polygon to be Ethereum scaling and infrastructure hub that will support innovation and help Ethereum go through this transitional phase of infrastructure maturity, if you will. And yes, basically it's kind of a overlay thesis on top of all these flavors that we try to introduce today. So basically all of them have their trade-offs, all of them have their merit. So we just need to kind of facilitate and allow innovation to happen and see where that will kind of take us in the years to come.
Awesome. Thanks a lot, Mihailo. And I think we are already, we've exhausted our time.
So,
sorry, Karthik, for thanks a lot.
Yeah, no, Mihailo, Sandeep, thank you so much for that talk and a really good overview of what's happening. And I largely agree with everything you said. Mihailo, at the end, is a very contrarian opinion, but I sincerely hope you're wrong, because that's when the whole ecosystem gets to move forward really faster. So thanks again for the talk today. And
moving faster is not really always the best thing. As a human being,
Absolutely.
also like to move faster, but it's not really always the great way.
It's about the compounding, not the velocity. So
yes.
That's
But I totally hear you. Sure.
But yeah, with that, thank you so much.